This is Greg Troutwine with Maritime Reporter TV, and we're here today with Matt Hart, Manager and Platform Leader, Marine and Stationary Power Systems at Wabtec, to discuss the multiple technical and regulatory trends driving the development and delivery of marine propulsion solutions today. So Matt, to start us off, can you just give us a brief personal and professional background leading to your current position at Wabtec?
Yeah, thanks, Greg. I grew up outside of Rochester, New York. I graduated from the University of Notre Dame with a mechanical engineering degree and started at the General Electric Company in the Edison Engineering Development Program, doing the rotations, primarily focused with our new Tier 4 locomotive product. From there, went into the area of engine performance, calibration, emissions, and combustion research, getting my master's in mechanical engineering from Georgia Tech. And focused with GE into our Tier 4 and our FDL loco modernization programs. I went back to school again after that to get my MBA at Gannon University here in Erie, PA. And leveraging that opportunity, moved into our engine platform team with Wabtec at that time, leading key reliability cases and our key maritime projects. And that led me to the role I have now as the platform leader, responsible for product development and install base support across our full engine technology organization, and leading our marine stationary systems team.
You know, to give our viewers and readers some perspective, can you give us a by the numbers look at Wabtec today, including its footprint in the maritime sector, using the metrics of your choice?
Yeah, absolutely. Wabtec as a whole, Fortune 500 company based in Pittsburgh, Pennsylvania. It's about 8 to 9 billion in revenue across freight and transit business segments, serving customers with OEM equipment, Tier 1 supplied equipment, subcomponents, product lifecycle services, and digital intelligence solutions that help revolutionize the way the world moves for future generations. We're based in 50 companies, over 27,000 employees. We've got 50 years of engine manufacturing experience with over 30,000 engines produced across all our applications. Specifically for the maritime sector, the maritime business is a group within our freight equipment organization. We've got over 1,000 engines in service or commissioning, primarily powering customers in the workboat sector, including dredges, river tugs, harbor tugs, ATBs, ferries, and medium-sized cruise vessels.
You know, I know most people watching this know the Wabtec name, but can you help me kind of put some meat on the bone? And with that, I mean, can you give me a quick overview of the Wabtec marine engine lineup with insights on the technical aspects that you see that make it unique in the marine propulsion space?
Yeah, Wabtec's first marine engine was introduced in the late 60s for lower legs towing, which was our V228, or FDL as it's known in the rail industry. Fast forward to the 1990s, 2000s, Wabtec was offering a marinized version of that V228 product that's named for the bore size in millimeters. With the advent of emissions regulations for the EPA and the IMO, Wabtec took its Evolution Series product and moved that into the marine space for the 250 MDA and MDB product that's offered now for primarily IMO 2 applications. In 2015, when Tier 4 and IMO 3 was coming about, Wabtec offered a marinized version of its Tier 4 solution, which is very unique, achieving Tier 4 levels of particulate matter and NOx without the use of after treatment, without urea, which really sets the product apart in unlocking the logistical flexibility and life cycle cost savings for our customers.
You know, I know from our previous discussions, and in fact, our previous meeting at the Wabtec plant, which is now about 2 years ago, that marine power is a small part of the cumulative Wabtec power portfolio. So when you look at the Wabtec power platforms cumulatively, from an engineering perspective, how does the marine power lineup benefit from experience in the rail, stationary, and offshore sectors?
The first and foremost is the design robustness. When we talk about the rail application, one of the things that come to mind is tunnel performance, extreme environment performance, as well as long maintenance cycles. So serving our customers through improved life cycle cost trade-offs. It also allows us to do concurrent design and reliability demonstrations. We're able to learn across both applications to make them better, where one application might be more extreme from another. So we can take the most robust design proven in all applications and apply it in the best manner possible. As well, the biggest piece for Tier 4, when we were developing that, especially in the rail industry, there was a really, really heavy push away from the use of urea for the logistics and the infrastructure that would be needed for it. So with that drive, that really helped prop up the unique marine solution that we have by enabling that push from the marines or the rail sector for non-urea to carry over, focusing our product around the no urea solution and getting that perfect and ready to go for the rail application, and then translating that over to the marinized product.
Obviously this is a transcendent time in maritime. It's a transcendent time in all industries led by decarbonization mandates, but also including automation and autonomy. Can we start with the big one, which I guess would be emissions reduction and decarbonization? Can you discuss in detail the various R&D programs ongoing at Wabtec today that are aiming to cut your engine's emissions?
Yeah, Wabtec is committed to offering alternative fuel solutions across our inline and V engine families for the 250 millimeter bore. We've got over a decade of dual fuel operation on diesel fuel and LNG on the product, as well as biofuel blends up to 100% are in operation already today. We're running on biodiesel and renewable diesel blends, and Wabtec is looking to expand and unlock additional biofuel capability for our customers while maintaining our high standard of reliability and compliance throughout. When we're investing in the low carbon fuel technologies with alternative fuels programs that are targeted at hydrogen, methanol, ammonia, and the 250 millimeter bore engine products are designed with that in mind: 250 bar firing pressure, minimally invasive engine adaptations that allow top deck and fuel system changes only in transitioning to low carbon fuels. And when customers are ready, when and if they're ready, we want to be ready to support them. One of the big research and development opportunities that we have is with Oak Ridge National Lab and Argonne National Lab for single cylinder research and combustion research modeling, where we're exploring and optimizing what that future technology will look like and working with our customers to determine what their requirements are for fuel flexibility will be in the future.
And I know you went into the fuels pretty deeply on the last question, but can you, I guess, kind of peel back the onion a little further on alternative fuels? Because I know there is no silver bullet solution, but do you see a fuel that's most promising today to eventually supplant diesel, whether that be on its technical capability or a regulatory environment?
I think the answer is going to be it depends. And it's going to depend by the geographic region you're in, by the customer you're at, the fuel proximity, fuel supplier proximity to that customer. It's really going to vary greatly. And I think the regulatory environment, the logistics environment is still unfolding dramatically, and is changing year to year, month to month. So in short, I think it depends, but we're going to be ready for all applications, customer interests that we want to make sure to be ready when they're ready for that transition.
And I know you're looking at a lot of different fuels potentially on your engines. When you look at it holistically, when you're trying all these different fuels, are there particular technical areas on the engine that warrant special attention or investment to make sure that they stand the test of time for whatever industry they serve?
Yeah, one of the big components is going to be the cylinder head, based on the requirements of the customer for multi-fuel use. What substitution ratios they require is going to determine what kind of fuel injection system is used: port injection, low pressure, medium fuel injection, high pressure, direct injection. That's going to dramatically change the fuel injection technology and the cylinder head design. Could be potentially multiple injectors fitting in that cylinder head. So we're looking ahead as a product that can be primarily fuel system and top deck, so that cylinder head and power assembly changes only to be able to serve our customers with the maximum flexibility. Another big one is depending on the injection technology, like we talk about hydrogen, with high pressure, is driving towards a cryo fuel pump, which is something that really, quite honestly, does not exist in service. Is being invented by a number of companies out there. So that's another key area that we're looking at and investigating to serve our customers to be ready.
So, getting off the decarb for a moment, another topic that's kind of pervasive across everything that we do is the lack of mariners, the lack of technical talent to keep ships running. And particularly, it's going hand in hand as we move toward more automation and full autonomy. I guess my question is, can you discuss how and if the macro trends are impacting Wabtech engine design today and preparing for a future when there are fewer people on ships at sea?
Absolutely, it's something that we're taking to heart very readily. Designing for long maintenance intervals, one, to make sure that our engines don't have to be touched from a maintenance perspective, to allow longer unmanned operation. And just recently in 2022, we released a new technology to our engine, an automated blowdown strategy to allow an unmanned engine room to ensure that there wasn't a coolant leak before that engine was started up, and potential damage would ensue from not doing that blowdown. So that was just one example of a technology that we introduced, and have rolled into our product, especially for like an ACCU notation vessel.
Can you discuss in detail one recent case study, a ship or a series of ships running Wabtec engines that you think highlights the cumulative strength of the Wabtec offer to maritime, from an engineering through delivery to maintenance?
Absolutely, yeah. One of the national security multi-mission vessel, which Wabtec has 4 16V 250 MDC, our Tier 4 product, powering each of those with propulsion and auxiliary loads. A series of 5 vessels that'll be delivered to the maritime academies in the U.S. And that was a major accomplishment, win for us. We're really proud to power the NSMV vessels, proud to be the engine that mariners are going to learn on for the next 20, 30, 40 years on those vessels. We put a lot of time in the factory into making sure that those were produced right. We put a lot of time into the commissioning of those with our channel partner, Cummins Sales and Service, in cooperation with their customer, GE Power Conversion and GE Vernova now. And I think those really highlight what Wabtec is all about. Serving the community and empowering impactful vessels.
One final question. Every job has its challenges. What do you see as your biggest challenge in helping to create an engine lineup that both fulfills the needs of your customers today, while eyeing the market and the regulatory-driven challenges of tomorrow?
I think what you already touched on, Greg, of the regulatory environment changing, the fuel needs of our customers changing, when the supply chain and the logistics catch up for green methanol, hydrogen, ammonia production, where we're truly really decarbonizing the fuel itself. That's going to be the hardest part for us, is when is that transition going to happen? What are customers going to want from substitution ratios? Is the onboard storage for those fuels going to be there in the transition from diesel? So that timing and that technology and that customer requirement and that partnership really with the customer to drive what technology do we need to put into the product to enable you to meet your goals of life cycle decarbonization, cost, and on-time mission reliability. We need to make sure that is held to a really high standard, and it's very difficult to predict that. So it's a constant learning process with customers. We have a lot of conversation with customers, trying to learn more about their goals, their wants, their needs as we move through this transition, and working with them to make sure we're ready to power them, and we'll be proud to power them when that transition comes.